My presentation is regarding AI music generation and how to use that to help better creativity. So for the introduction, um, in the music creation process, musicians often experience creative blocks. So I'm a musician myself, which is why this has been very important to me. And while I was trying to make my own music, I found that oftentimes I would come to time periods where I just couldn't create anything, like just nothing. And for beginners to music or those who have not had an extensive music background, um, they may find composing to be very scary because it is a very scary process, and it takes a lot of time. And even for musicians like me who have had a lot of experience, it still does take a lot of time. So my solution to this, by using AI, Music Gen is able to take music input that produces audio-based output. So um, users can put in a recording of some music that they play and a prompt, and Music Gen, which is my app that I developed with my partner Edmond, they're able to get some output from their music, right? Okay, cool. So some challenges that I faced during this process, a significant one was what models to use. So with a type of app like this, there's a lot of things to consider to make sure that a model is the right fit. For example, it has to be able to process the user's input, right? The prompts and the audio file. So we had to make sure that it was powerful enough to, when those things got more complicated and long, it didn't take a super long time for the user to get its output, which leads me to the next thing. It's efficiency and speed. So with an app, you have to make sure that it doesn't take too long for the user to get their desired output. The second issue is storage. There needed to be a way to let the user retrieve the music that was created that wasn't just on the local device so that the app could be as space efficient as possible. And then lastly was the interface. So how to make an app visually appealing and have um just be an overall good experience. So here, this is the solution. Um, Overall, it's a very simple system. Begins with the splash screen. The user has the generation. They're able to select a file, prompt, and whatever. After that, it goes into the music engine. And then the user will get the result. And then the server and database is for holding that result. And we'll go into depth about each of these elements, kind of. Okay, so I discussed the problem for choosing an AI engine, and the solution we ended up deciding is to use Meta's AI system because of its extensive data set. And so Meta was able to accomplish everything that we needed in an AI system. So it was able to take the um re recording input and text input, and we put it through tests with longer prompts, and it still provided a result quickly. So let's go on to the next one. Server and database. So our solution was to use Firebase, which was a cloud-based platform. And so because it's on the cloud, the users, when they create the data, it gets moved to the cloud off their device. And then, which brings me to the data cleanup process. So it gets moved from the local device to the cloud. And then the temporary files are then deleted off the user's device. And then the user interface. So the UI is implemented using Flutter, which is a cross-platform framework, which lets the app run smoothly on both Android and iOS. And it has a lot of pre-built customization options, which make app creation easier. And so yeah. So this is the project demo. Here. Let's see. I hope you guys will be able to hear the audio. But here, you select a file and you put in any prompt you want, hit generate music, and it'll take a bit. So after the file is generated, um, users will have multiple options that they can do with the file, as you'll see showcased in a little bit here. You can play the file with the slider and then it'll show up in your music. You can favorite it, unfavorite it, and then click and I'm showcasing the music here. So in the Explorer, there's a bunch of default music that users can download to help them get started, and they can download that and then put it as their file. And all of um the pre-included music are generated using my app, based off of the theme, like for classic Mozart or yeah, stuff like that. You can change the duration of your generation. And here I go with a different prompt. I hit generate again. So this time I'm generating using one of the pre-given music files. And I'm doing it for longer, so 30 seconds instead of 15. And now we can see what um the music sounds like. Very jazzy vibe, which is good. That was a prompt. And yeah, so that was the demo. And then next one. So we did run a couple of experiments. And for the first one, we wanted to look at how accurate is the program, right? Can the AI satisfy what the user wants? So if we look at this graph, we have a bunch of like types of prompts. So these are the ratings that are given by users. So like 10 would be perfect, 8 is good, and so and so. So if we look, the highest is the simple text prompt, and then the lowest are abstract prompts, right? And everything else falls somewhere in between. So as you can see with abstract and more complex text prompts, the AI has a harder time generating a good result. Whereas with simple text prompts, the AI is generally pretty good at generating what the user wants. So this is showing us that in the future, uh there needs to be some way to get the AI to be able to process and generate better results for more abstract prompts or complex texts. The second experiment is how long the AI takes when generating music, which is definitely a factor for the user experience, like I mentioned earlier. So, as the chart goes, it goes from small basically to kind of large with complex, like very long. And you can see the increase in slope here. So similarly, with smaller, simpler prompts, the AI has no issue with generating. But with more complex audio, the AI has more of an issue. And large audio compared to complex text, it's like fine. So that also tells us that the AI model has a bit of a harder time. So maybe we need to implement some sort of like compressor or something to help the AI with that. So some related works, the article Meta MGC is a music generation framework for concerts in the metaverse by Jin and et al. And it proposes a comprehensive framework for enhancing the musical experience in metaverse concerts. And it introduces a neural rendering method for generating spatial audio. So this framework aims to deliver a more immersive auditory experience. And however, this may be limited by the complexity of its neural networks and the computational resources required for real-time processing. While my project improves on this by optimizing the AI model for faster and more efficient music generation, ensuring a smoother and more accessible user experience. The second paper is by Kalia Castosa and Papa Castosa and L. It reviews several AI methodologies for music generation, including non-adaptive methods that depend on user input and probabilistic models that learn from data and evolutionary approaches that allow user interaction. And this review provides a comprehensive overview of the strengths and weaknesses of these methods, which offers insights in how future AI systems might evolve, which benefits my project, and my project builds on these methodologies by optimizing AI models for faster and more efficient music generation. The third one, Patil et al., it provides a systematic survey of AI-based music generation techniques, particularly focusing on deep learning models like RNNs, LSTMs, and GPTs. The survey highlights the challenges of evaluating AI-generated music, including issues related to creativity and copyright. My project aims to address these limitations by enhancing the model's ability to generate musically coherent and creative compositions, leveraging users' feedback for continuous improvement. So for future development, something I would add is AI-driven music personalization. So for example, after you generate music, you could provide feedback about what you like about it, what you don't, if you like it, if you don't like it, and the AI recognizes that and it starts to build a profile of you, and in the future it will cater the music based off of your tastes. The second thing is collaboration mode with real-time sharing. So after the app gets more complicated and adds more features, collaboration mode would definitely be something I would be looking to add, as I feel like that is one of the most important aspects of music. Like one of the most meaningful is working on it with someone else. And so that would provide a sense of connectivity. And to go along with that is more detailed customization options for advanced users. So there would maybe be a option to choose keys options for specific tempos, just more detailed customization. And so the conclusions, um, so we showed the results of AI-driven music framework, but there were several limitations. And so one limitation is the model's performance with complex inputs as shown. And then like we discussed, abstract, large audio files. So further optimization of the AI model, right? So it could be through including more diverse training data or enhancing the processing algorithms to handle wider range of input complexities. And for the issue of cloud-based processing, which could include introduce latency issues for internet connectivity. A potential improvement would be developing a more efficient local processing option or hybrid that balances both local and cloud-based computation. And so to conclude, sorry, give me a second. To conclude, my project shows a lot of promise. It's AI-driven music generation that addresses the creative stagnation among musicians, and by optimizing the model for better performance with complex inputs and improving the overall experience, this framework has the potential to improve music creation and elevate the metaverse concert experience. Cool. And here is my contact info.